Welcome, everybody. Today we're going to be going over for chapter three, lesson three. We're going to be working on solving equations by using multiplication and division. In the previous lesson, we worked on solving equations by addition and subtraction. So this lesson will be very similar. So what we're going to learn, right? How to solve equations by using multiplication, and how to solve equations by using division. So a couple of key things to remember is um, just like before where we use the addition and subtractions properties of equality, this is going to lead us into the multiplication and division properties of equality. So here's the key concept here, right? If each side of an equation is multiplied by the same number, it results in an equation that is true. So here's an example here. If we have 6 equals 6 and we multiply both sides by 2, both sides of the equation remain equal. You have 12 equals 12. 9 equals 9, multiply both sides by -3, and you get that both sides are still equal. Both sides still equal -27. And so just like before, whenever you take both sides of the equation and you multiply it by the same value, you still remain with an equation that's true. Both sides still stay equal. Okay, and so this is the same idea as before with addition and subtraction, but now we're going to be using multiplication. So let's look at an example. So how do you solve an equation using multiplication? So here we have an equation. It says solve t over 30 equals 7 over 10, and then check your solution. So just like before, we're going to check our solution, make sure we did it all right. So here's the original equation, right? Important to write that down. So t over 30 equals 7 over 10. So right now, t over 30 is the same thing as, or equivalent to saying that t is being divided by 30. And so again, in order to isolate the variable, we want to get it by itself by getting rid of that 30. So the opposite of dividing by 30 would be to multiply by 30. So when I multiply both sides by 30, I'm using my multiplication property of equality, making sure that both sides remain equal. But what ends up happening on the left side of the equation is that when you multiply by 30 and divide by 30, these two will cancel each other out. When you multiply and divide by the same value, they do cancel each other out. And so it'll leave me with t on this side, and I have 21 on this side. Just for simplicity's sake, just know that uh, that 7 over 10 multiplied by 30 does give you 21, because it would be like 7 over 10 times 30 over 1. So 7 times 30 gives you 210. 10 times 1 gives you 10. And then 210 divided by 10 would give you 21. So if you need help simplifying that, let me know. Now we're going to check our solution. Does in fact t equals 21 actually check out? So let's go ahead and do that. First, we got to take the original equation. We're going to substitute out our variable t for what we say the answer is, 21, and see if the equation is true. So I'm going to go ahead and substitute 21 in for t. So I have 21 over 30 should equal 7 over 10. And if you simplify the two fractions, right, both 21 and 30 are divisible by 3. And so 21 divided by 3 is 7. 30 divided by 3 is 10. So it does give you two equivalent fractions. 7 over 10 does equal 7 over 10. So the solution is 21. It does check out. Let's look at a second example. Now we're going to solve by multiplying by a fraction. So here we're given a problem 2 1/4 times g equals 1 1/2. So these are mixed numbers, right? These fractions are mixed numbers. And so one of the easiest strategies for dealing with mixed numbers is to convert them into improper fractions, right? So there's the original equation. So what I'm going to do is I'm going to go ahead and convert these into improper fractions. So 2 1/4 is equivalent to 9/4, right? 2 times 4 is 8, plus 1 is 9, so 9/4. 1 1/2, 1 times 2 is 2, plus 1 is 3, so 3/2, right? So these are equivalent fractions, but now we rewrote them as improper fractions. And now we can go ahead and solve. So right now, 9/4 times g. So I'm trying to find g. I want to isolate g. So one of the strategies I can do is by multiplying by the reciprocal. Because if I multiply by the reciprocal, what ends up happening is these will cancel out, right? 9 and 9 will cancel out. 4 and 4 cancel out. And then on the other side, if you forgot how to multiply fractions, you just multiply straight across. 4 times 3 would give me 12. 9 times 2 gives me 18. and then I would reduce or simplify 12 over 18 into the equivalent fraction of 2 over 3. So 12/18 is equivalent to 2/3. Okay, so the solution is 2/3. So here, whenever we have mixed numbers, it's much easier to convert them into improper fractions. Those are much easier to deal with when you're working on these problems. Let's look at another example. Solving using multiplication by a negative number. So here I have solve the equation 42 equals negative 6m. So I'm going to go ahead and write down the original equation, and I'm going to solve it. So here I have m, and I want to isolate it. I want to get rid of the negative 6 there. So one way to do this is to multiply by negative 1/6. And when I multiply by negative 1/6, right, negative 1/6 times negative 6, negative times a negative is a positive. 1/6 times 6, right, it's the reciprocal, right, because negative 6 is just negative 6 over 1. And those two will cancel out, right? So these will cancel out, leaves me with just m. And negative 1/6 times 42 gives me negative 7. And so that would be my solution. The solution is negative 7. All right. So this one you could multiply as negative 1/6 over 42 over 1, right? And then simplify. Or multiplying by negative 1/6 is also equivalent to dividing by negative 6. All right. So let's look at another example. Write and solve an equation using multiplication. So here we look in a little space travel. On July 20th, 1969, Neil Armstrong stepped on the surface of the moon. On the moon, his suit and life support backpacks weighed about 33 pounds. So the problem says, refer to the information about space travel. It says the weight of anything on the moon is about 1/6 its weight on Earth. What was the weight of Neil Armstrong's suit and life support backpacks on Earth? All right. So let's examine this problem. So the words that I'm looking at here that's going to help me solve this problem, it says 1/6 times the weight on Earth equals the weight on the moon. So when I want to, what I'm looking for is what was the weight of all his life support backpack on Earth, right? So W is going to represent my variable, my weight that it's on Earth. So that's the unknown. That's what I'm looking for. And so now I'm going to write an equation to represent the situation. So I know that 1/6 times whatever the weight on Earth is equals to its weight on the moon, right? And that's from this information from the problem, right? Because it says that it was 1/6 the weight, right? So if I took the unknown, right, the weight on Earth times 1/6, that's going to equal its weight on the moon. So there's my equation, right? And I know that its weight on the moon is going to be smaller than its weight on Earth. Things are going to be heavier on Earth than they are going to be on the moon because there's less gravity, right? So let's see if this actually checks out. So if I solve this equation, there's my equation, 1/6 W, right? 1/6 times the weight on Earth equals 33. And so what I'm going to do is I'm going to solve this equation now by using multiplication. So if I wanted to solve for W, I'd want to multiply both sides by 6, right? I want to cancel out that fraction. So I'm left with just the variable. Because again, if you multiply and divide by the same value, right, it ends up canceling out. So that's going to leave me with W here. And 6 times 33 is 198. So Neil Armstrong, with his suit and life support backpack, his equipment on Earth actually weighed 198 pounds, but on the moon only weighed 33 pounds. Which makes sense. Less gravity. All right, let's look at the next problem. So we've worked on now using multiplication. Now we're going to use division. So we're going to use the division property of equality. So here's our key concept here. Same idea as with addition, subtraction, and multiplication. Division property of equality works the same way. As long as if each side of the equation is divided by the same value, the resulting equation will always be true. So here's an example, right? 15 equals 15, and you divide both sides by 3, you still get 2 equal sides. 5 equals 5. Over here, we have 28 equals 28. You divide both sides by -7. You still get both sides are equal, right? -4 equals -4. So let's use this to actually solve a problem. So let's solve this equation. and check our solution. So we have 13s equals 95. So I write down my original equation. And I'm going to use division here because I'm solving for s. It's being multiplied by 13. The opposite of multiplying by 13 would be to divide by 13. And when I divide both sides by 13, these two will cancel out, leaving me with just the s. And 195 divided by 13 will give me 15, right? And then let's go ahead and check it out. In my original equation, I'm going to substitute s for my answer, which was 15. And does 13 times 15 equal 195? Yes, it does. 13 times 15 does equal 195. So both sides are equal. That means that my answer made the equation true. So therefore, my solution is 15, right? S equals 15, and this checks it out. All right. So solving using division again, but what happens if I have negative numbers? Well, remember, negative numbers doesn't change anything. We can still use our division property of equality. So here I have negative 3x equals 12. So in order to isolate for the x, right, I want to divide both sides by negative 3 because I want to cancel it out. So when I divide by negative 3 here, the negative and the 3 cancel out, leaves me with just the x. And 12 divided by negative 3 gives me negative 4. So here's my answer. X equals negative 4. Let's look at one last example. So here we want to write and solve an equation using division. So it says write an equation for the problem below, then solve the equation. Negative 18 times the number equals negative 198. So there's negative 18 times the number equals negative 198. So when I'm writing my equation, obviously negative 18 times n, right, a variable, a number, equals negative 198. And here I get negative 18n equals negative 198. That's my equation written out in a more succinct way. And now I'm going to solve it. So if I'm solving for n, I want to get rid of multiplying by negative 18. So I'm going to divide by negative 18. So when I divide both sides by negative 18, these two guys will cancel out. And it leaves me with n equals, and then negative 198 divided by negative 18 is 11. And that's my solution. And again, you can always check your solution by substituting your answer back into the equation for the variable to see if it checks out. All right, thank you for watching. See you next time.